Okay, so Leetcode practice time. So two goals in this video. The first one is to see how to solve this problem, and then we are going to do some coding work. And the second purpose is to see how to behave during a real interview for this coding question. So let's get started. Remember, the first thing in a coding interview is to always try to understand the problem first. And if there's anything unclear to you, please ask some clarification questions. And also think about some edge cases, which you need to take special care of in the next step. So let's see. Given a list of the counts and each element of count I is a list of the strings, where the first element of count I0 is a name, and the rest of the elements are emails representing the emails of the count. So now we would like to merge these accounts. So two accounts definitely belong to the same person. If there is some email that is common to both accounts. Okay, note that even if two accounts have the same name, they may belong to different people, as people could have the same name, okay? And the person could have any number of accounts initially, but all of their accounts definitely have the same name. After merging the accounts, return the accounts in the following format. The first element of each account is a name, and the rest of the elements are emails in sorted order. Okay, so the accounts themselves can be returned in any order. Sounds good? So let's take a look at this input example. So we have the accounts. So first one is the name John, and the John has two email address, and the other John has one email address. Then another John has two email address, and the Mary has one email address. So it seems like this John and this John, they are the same, and this is a separate John, and Mary is separate. So the output is something like this. So let's see some constraints. So counts will be in the range of 1 to 1000. Okay, and the length of accounts I will be in the range of 1 to 10, which means some name may not really have any email. Does it mean that? Okay, so the length of ij is in the range of 1 to 30. Okay, sure, I think I kind of understand it. So I think the question I have in my mind is, it says that accounts I will be in the range of 1 to 10. So if it is 1, then it means the account doesn't have any email address. So for this case, I was thinking if we need to output it in, we need to consider it in the output. So that's my first question. So other than that, okay, I cannot think of something from the top of my head like the second question. So that's the only question I think I have currently. Okay, so I'm not sure how to do that, but let's assume that it wants us to generate the account that has no email in the output. So the second one is to find the solution for this one. So I think I think the solution is yeah, so okay, so how to solve this problem? So I think the solution would be, I think this is a graph question. So if we consider each email address as a node, and then we build a vertex between the nodes, actually we just find the the separate connected components within the whole graph, and each component is going to be each component is going to be a separate merged account. Okay, so let's see how to. I would say first two steps. The first step is to generate a graph, and the second step is call something like DFS on top of it. So yeah, I think that should work. So regarding the runtime, so let's see if there is any other limitation for the output. So after merging account, return the accounts in the following format. The first element of each account is the name, and the rest email in sorted order. So it seems like we do need to sort it. Okay, so I would say the runtime in total would be, so let's say it really depends. So let's say average, the average size of each account is m, and there are n separate accounts. So then it would be m log m and times n. So this is how many accounts are there after merge, and this is average size for each account. Average size for each account. Okay, so I think that's clear to me, pretty clear in general. But one thing we need to consider is, what if there's no email address for a name? So that one is pretty much something we need to take special care of. So other than that, I think we should be good to go. Yeah, so let's see. We should okay, so let's see. The third step after we find the solution is about coding. So for coding part, we care about the correctness and of course the readability, and of course the correctness, readability, and also of course the speed is a factor to be considered. So first of all, we need to get a graph. I would say we need two things. So the first map is from the email to the name. So this is email name map hash map, and the second one is the graph itself. So the graph should be map from the string to the string. Actually, for each email there could be several things, several edges. So I would say this one is a list, or maybe a set. So could be a set, I think. So this is the email graph. Alright, so let's go through the and maybe we need to define the return list. List of the what is that? List of the string. So which is how do we call it? So the accounts set to merge in any order. Let's say merged accounts. New linked list. Okay. Okay, so the first step is about generate a graph. So the graph doesn't need to be very complete. It just need to, because we just need to use it for DFS purpose. So instead of like connecting each node in the connected components, we can just we just need to make sure that for the connected component there could be an edge or vertex to a node, to a node, which makes the node accessible when we do the DFS at the next step. So I'll say list of the string account, and this is accounts. Okay, so the first one is the name, so string name is equal to account dot get 0, and the rest of them are email address. So if account dot size is equal to 1, which means there's no email address for this name. So what we could do is we could just generate a linked list string merged account is equal new linked list. Okay, yeah. So merge the account dot add account dot get 0. Yeah, so maybe you still need to put it back here. So we are going to add a name here, okay, and then we are going to say merged accounts dot add merged account. Then we just continue. So otherwise it means there is at least one email there. So what we are going to do is we are going to say okay, I'm going to connect all the other emails with the first email. So what if there's only one email for this account? So if there's only one email for this account, we actually don't really need to do anything, but it's okay if we have it to be self-connected. Okay, so int I is equal to 2, I is equal to 2, yes, I is smaller than account dot size, what is that, account dot size and plus I. So first of all, actually we can just start from the first one. So from the first email we are going to just have email name map dot put let's say just a string email is equal to account dot get I. So we are going to put the email and the corresponding name into this map, and that's the email graph. If email graph dot contains, if not email graph contains the email, okay, so actually I need to get the first email. So we should be the first email to the rest of that, and the rest of that to the first. Okay, so let's say string first email is equal to account dot get 1. Alright, and then email name map dot put the first email and the name. Okay, and for the rest of the email we are going to generate the graph. So if not email contains email, then we will say okay, email graph dot put that, it should be the email new hash set. Okay, and then we will say okay, email graph dot put okay, so email graph dot get email dot add the first email. Okay, and similar here, if email name map dot put if email if it doesn't contain the key, if this is email graph, if email graph doesn't contain the key, so if it doesn't contain key, okay, if it doesn't contain the first email, then we are going to say okay, email graph put what's that, the first email and the new hash set. Okay, alright, so yeah, so this contains key. Okay, and then we are also going to say okay, email graph dot get first email dot add the email. Alright, so until now we have already get the email graph settled down, and also we have the email name map settled down. So the next step is to call DFS to find the connected components. So find the connected components. Alright, so how to do that? Let's see. So for the DFS, we are trying to find the connected components. Alright, so I think I kind of know it. So first of all, we need to define something called the visited, or maybe seen email, which means we don't need to visit our emails in the seen email anymore, because in DFS we just need to visit each node just once. So set email is equal to new hash set, and then for each of the email, for each of the email, so let's say string email, the email name map key set. So we will say alright, string name is equal to email name map dot get. I'll get the email for get the name for this email, and also at the same time let's call define another option. Let's say it is void find connected component. So in this one we are going to pass the email graph, and also if this is seen before, so this is seen email, and also we are going to have we need to define a set of the not really, so actually it could be just a list of the email. So we define a list of the email in the, so this list means the current emails we find in this component. So this is email list within the same account. So we are going to say, all right, you call find connected component on top of the email graph, and then it is seen email, and each time we are going to have a list of the string. This is email list is new, maybe linked list. So this one I would say email list. All right. Sure. So let's try to do some coding work on this find connected component, because this is the most juicy part for this DFS thing. So if alright, so actually I missed something, which is the email, which is a starting node here. So if scene email dot contains, if it contains email, we pretty much just return. Otherwise, we will first have scene email dot add the email. We have the scene email, add the email, and also we will have the email list dot add the email as well. Okay, and the next step for me to do is actually to go through. All right, so do I need a? I'm thinking if I need this set for this email list, because no. So potentially we actually, so because we have used a scene email to control it, so we don't need to do it. So we will say, okay, string connected, let's say just neighbor, or connected email from email graph dot get, let's say this email. All right, so we will visit all the connected email. So we will call the find email connected component for the email, connected email, and also the email graph, and this is the scene email, and also the email list. All right, so that's mostly it. So after calling this find connected component thing, I would say this is if scene email dot contains the if it contains the email, we just pretty much skip it. So if it contains this email, we just continue it. Otherwise, if it's not seen, we just find the email list, and I think it's collections dot sort. This is email list. So we sort it, and then we will put the merged accounts dot put dot merged accounts dot add. Okay, this is collections dot sort email list. So I will say email list dot add first add. Okay, add 0, and it should be the name on top of it, and then the merged account would be, okay, we will add email list into it, and then finally we just return the merged accounts. Okay, so I think we are mostly code complete with this. So to and the next, but it's not done. The next step is always to do some testing. So for testing, usually you don't have a runnable platform, so usually you just need to do some sanity check by going through an example, run it manually, and at the same time explain how this piece of code is gonna work, and also set up some other test cases to increase the test coverage. So let's go through one example and see how it works. So let's use the first example. So for this, actually, this one is a bit. We would just replace the email with some simpler thing. Let's say this one, John Smith at email is a John Smith at mail as a John. This is Mary. Let's say it is M. John 00. Let's say if it is B, and this is C, and this is the D. All right, so let's see. So first of all, we have the email name map. And the next one is email graph. So the email name map, first of all, if account size is equal to, okay, so if account size is equal to 1, which is not true for any of them, so this one will never be reached here. And then we find the first email for John, which is A, and we put okay, so and then we put the email name graph here. Okay, so it's gonna be A and John, and then we will say, alright, so we are going to build you the graph, and currently for the email graph we have the first, you put the first email. Okay, the first email will be A, and then it is a set of stuff. Currently it's empty, and then we go through the rest of the emails, and first of all we will get the email, and then we put it into this I would say this B John, and then if it now contains email, then we put it into it. Sounds good. And then we are going to say, okay, email at the first email, which is B here, and then the first email will first, oh, this one is A, and then we put it B. Okay, so now the graph is something like this. Let's see the second account, which is D. So after the D, we would have the D to John, and at the same time we have the D and to something empty. Alright, so the next stuff is John and AC. So we would say, okay, we would add another one which is C to John in the email name map, and at the same time we will put this A. First of all, we will put a C to empty, and another thing is we will set put C. Okay, so put C at the first email, which is A, and then the first email at the current C, which is, okay, so we currently A has the value which include B and C, and then the next one comes to M, so M maps to Mary, and then we will say, alright, so we are going to have the email graph, which is going to be M to empty. Alright, so that's after the first step. We are going to generate the email graph, and the email name map has this one, and then we will find the connected components. So for each email in this email name map, so first of all you find the name for it, okay, and then the scene email, let's say we start with this one, and the scene email doesn't contains A, so it's good. Then you find the component, we call the find component, so you would say scene email currently is equal to something empty. Okay, so call on A and the graph and the scene email and the email list. So if scene email, so currently the email list is empty as well. Scene email doesn't contain it, so you add the scene email to A, and also as well we are going to add this into the email list. Then we will say the connected email would be B and C, and then we call the corresponding function. And furthermore, we will update the C email as B and C, and the email is extended to B and C. And then in the final merge the count thing, we are going to have, so we are going to have alright, so we are going to have so it is drawn to A, B, and C. Alright, so the next time we are going to email list is going to be empty again, and we are going, the next one suppose is B, because it is, it is included scene email, so skip it. And for the D, we are going to call it, and then add a scene email with D and update the email list with D. So yeah, and there's no edges, and so we are not going to call the recursion here. And finally we are going to have the drawn with D. So similarly with Mary M. So finally I think we should be able to return something which makes sense to me, I would say. So let's give it a shot to run this piece of code. Alright, so it's accepted. Let's do a submission. Alright, so yeah, so that's it for this coding question. So I think one thing definitely need to mention, during the sanity check we didn't check one part, which is suppose there is some account which doesn't have any email, so that one it will touch this if branch. So if we include something which has the name but no email in the input, I would say that should be perfect regarding the test coverage. So that's it for this coding question. If you have any question about this puzzle, please please leave some comments below, and if you feel this a bit helpful, please give me a thumb up, and I'll see you next time. Thanks for watching.